Example 1. Most internet users utilize two-factor authentication to protect their online data. Consider the claim from the chapter problem that most internet users utilize two-factor authentication to protect their online data. Using the letter P to denote that the proportion of internet users who utilize two-factor authentication, the claim that most internet users, or the majority, is equivalent to the claim that the proportion is greater than half, or that P is greater than 0.5. So the expression P is greater than 0.5 is the symbolic form of the original claim. The big picture. Well, we have the claim that the population proportion P is such that P is greater than 0.5. Now, among 926 consumers, how many do we need to get a significantly high number who utilize two-factor authentication? Well, when it's clearly not significantly high, a result of 464 or 50.1% among 926 is just barely more than half. Clearly significantly high is that a result of 925 among the 926 or 99.9% is clearly significantly high. And then unclear, what about a result of 510 or 55.1% among 926? The formal method of hypothesis testing allows us to determine whether such a result is significantly high. Using technology. It is easy to obtain hypothesis testing results using technology. The accompanying screen display shows results from StatCrunch, so we can use computers or calculators to do all of the computational heavy lifting. So, examining the display, we see common elements. They all display a test statistic, which you can see over here. Let me make note here. So here, the test statistic is the z-stat. That represents the test statistic. So let's go ahead and highlight that. So our test statistic is the z-stat, and if you look here, if we round that to 1.25, okay, so that is the test statistic here, which is rounded. Okay, then we also have what we call the p-value, and that's also rounded. So there is the p-value, and the p-value is the probability of that success. And then here is our hypotheses, which represents our claim. So for an understanding of how the hypothesis testing procedure works and learn the associated terminology, only then will the results from technology make sense. So over here, let's take a look. Here's the proportion test, because we were testing the proportion. We can see here that 482 is the count out of the total of 926, and this says the sample proportion is 0.5205. Now let me show you how we get that result. If we take that 482 and then we divide it by the 926, that is the sample proportion, 0.520518359, and then this represents the standard error. So let's take a look at this screen. Okay, so what are the things that we need to make note from? Well, we want to identify the following. So identifying the following, we know that P from is equal to 0.5. Okay, and where do we get that? Well, we can see that we get that from the following. We get that from here. So there's p is equal to 0.5. Next, we need to take a look at 2. Okay, what does x equal? Well, x is the count. So the count here represents 482. Number 3, what is the sample size? Well, the sample size is 926. Number 4, what is the point estimate? Well, we just did that on the calculator. That is 482 divided by 926, which is then equal to 0.52051836. Okay, now number 5. Okay, what is the test statistic? Well, the test statistic is the z-stat, and rounded to 2 decimal places, that is 1.25, which is there. There is your point estimate, or the sample proportion. And then number 6, what is the p-value? Well, the p-value is equal to 0.106 if we round that to 3 decimal places. Okay, now, significance. Hypothesis tests are also called tests of significance. In section 4.1, we use the probabilities to determine when sample results are significantly low or significantly high. This chapter formalizes those concepts in a unified procedure that is used often throughout many different fields of application.